All right, so one more problem where we use our sum and difference formulas. And these problems involve inverses. And so when we work with inverse trig functions, we need to make sure that we are working in the proper quadrants because there are some limitations here. And so whenever you see an inverse trig notation in the number, like you have the inverse trig function of a positive value, your reference triangle will be in quadrant 1. If the value is negative, it's either in quadrants 2 or 4. It's in quadrant 2 if it's cosine, inverse cosine of a negative value, and it's in quadrant 4 if it's inverse sine or inverse tangent of a negative value. And so the first two steps are the same as the previous two examples. We need to actually draw two reference triangles, one for alpha and one for beta. And so what you just need to remember about inverse trig functions is that the answer to an inverse trig function is an angle measure. So that being said, in problem number 3, the expression cosine inverse of 1/2, the answer to that will be my angle alpha. So I'm going to draw a reference triangle representing alpha. And then the other inverse trig function there, the inverse sine of 3/5, that's representing our other angle, which is beta. So if you look, what the inside of my parentheses will give me is alpha plus beta, and then on the outside is sine. So I'm working with sine of a sum, which explains why I have that formula written over here, because that's what I'm going to use. So just realize inverse trig notation, basically the answer to an inverse trig problem is an angle measure. So we're going to draw our two reference triangles, and I did that here. Okay. When it comes to that first one, the inverse cosine, I use the fact that inverse cosine is positive 1/2. And all inverse trig functions, when they're positive, are in quadrant 1. So notice that I drew my reference triangle in quadrant 1. Cosine is the adjacent over the hypotenuse. And then I used Pythagorean theorem to find the third side, and it's the square root of 3. The other expression in this problem, the inverse sine of 3/5, that's telling me all about angle beta. It's inverse sine of a positive ratio. And so once again, I'm in quadrant 1. Sine is the opposite over the hypotenuse. And I use Pythagorean theorem to get that third side. So that's the first two steps in these problems. Draw a reference triangle for alpha, draw one for beta. And so now I'm ready to figure out what is sine of alpha plus beta. And so just like before, I'm going to find the value of these 4 functions in my formula. So I'm going to find the value of sine of alpha, cosine of beta, cosine of alpha, and sine of beta using these two reference triangles. And so I did that here, right? So I had sine of alpha. So alpha is that first triangle, and sine is the opposite over the hypotenuse. And then cosine of beta. So now I'm using the second reference triangle, and cosine is the adjacent over the hypotenuse. Formula has plus cosine alpha, so I'm back to that first reference triangle. Cosine is the adjacent over the hypotenuse. And then sine of beta, second reference triangle, sine is opposite over hypotenuse. So once I've actually gone and I found these 4 exact values, I can do my multiplication, and then I can combine these two fractions if possible. So when I multiplied the square root of 3 times 4, I simply got 4 root 3. Okay, because we can multiply insides with insides and outsides with outsides. We can't multiply like an insider and an outsider. It doesn't work that way. On the bottom, 2 times 5 is 10. And then 1 times 3 is 3. 2 times 5 is 10. And then I can't really combine my two numerators and get one simple number. It just doesn't work that way. So that's why I have 4 root 3 plus 3 in the numerator all over 10. And that's my final answer. And so that's how we work with our sum and difference formulas. We simply use them to find exact values of trig functions. We are working with two angles when we're using sum and difference formulas. So we're going to create two reference triangles, one for alpha and one for beta, using the given information. Once we have those two reference triangles, we should find any missing sides using Pythagorean theorem, and then we can calculate our 4 trig exact values. And so each of these functions does involve us finding 4 exact values. And then basically multiply and combine those fractions. There you have it. Those are your sum and difference formulas.